So we're going to go through a little bit of stuff today. We're going to go through a fair amount of stuff today. And so I want to, as we begin our journey together, I want you to note that I'm not expecting you to remember everything that we're going to talk about. I don't expect you to remember all of it, but I would encourage you to note that GitHub repository on the top of the slide there. That's for your own edification, for your own reference for later on. So don't worry about following along in that code base right now. Just take a photo of that and use it for your own reference for later. I'm also happy to answer questions. If you've got comments or feedback or anything like this, then don't hesitate to reach out to me. I'm here for you. I'm happy to answer questions. How many of you are on Twitter? Twitter. It's 2017. Twitter. Okay, well, the rest of you, get on it. It's the new IRC. It's the place to be where all the developers are that drive the open source that powers your business. If you care about the software that's underlying what you're doing, then you can find all the developers, all the stakeholders in these technologies online. They're happy to talk. We're happy to communicate. Indeed, that's how I first found out about this wonderful conference more than 6 years ago. So, Twitter's a great place to be. I'm also available to answer questions by email. How many of you have email? Email. Anybody? Okay, well I guess that's a thing as well, but I prefer Twitter. I love Twitter. Find me on Twitter. All right, now, a little bit about me. My name is Josh Long. Thank you very much for coming today. I appreciate that there are a lot of other great choices, and you decided to spend the day with me, or at least the hour, and I really appreciate that. A little bit about me. My name is Josh, as I mentioned. I'm an open source engineer and contributor to a lot of different technologies. I work on the Spring team as an engineer on several different projects. I am the #1 top-ranked, most highly regarded, most visible, consistently highest contributor of bugs, but still #1 contributor of bugs to projects like Spring Boot and Spring Cloud and Spring Integration and Spring Batch and VoidRun and Time Leaf and Activity. More bugs per commit than any other developer. It's something. It's all I've got. It's all I've got. I appreciate the sympathy. So there's that. And as I'm a Java champion. I'm a Spring developer advocate. And as part of that, I do my level-headed best to help organizations, community members, customers, that kind of thing, build awesome sauce software in terms of Spring. And a part of that, of course, is doing lectures like this very one here, which I'm honored to be able to do for now my 5th year. Well, not consecutive, but 5th year at this wonderful show. And also, I do articles and blogs and books, right? And I'm working on my latest and greatest book. That book is called Cloud Native Java. It's not quite done yet. We're 2 chapters away. It's Cloud Native Java. It's all about how to build applications that survive and thrive in the cloud at scale. How to build applications that benefit from the elasticity of the cloud using Spring Boot and Spring Cloud. By the way, I'm going to be talking about Spring Cloud in my next talk at this very show, I think the 28th, is that right, maybe? Look for Cloud Native Java in my name, and I'd love to see you there. But anyway, it's all about how to build applications that survive and thrive in the cloud at scale using Spring Boot and Spring Cloud. And, whoa, hello. My computer's still awake. Oh, there we go. I put even the computer to sleep. So anyway, it's how to build applications at scale that survive and thrive. And for those of you who are wondering, and I can see it in your eyes as I look upon you right now. I can see in your eyes that you're curious, you're wondering about what that animal is. The bird on the cover of that book. People wonder about this all the time. If you write a book for O'Reilly, it doesn't really matter what you say. People buy it because of the animal. Seriously, that's the only reason I've ever bought them. What about you? Is that true? No? Okay, fine. Anyway, that book is a blue-eared kingfisher. Oh, come on. Is this going to happen all day, or it's just not working? I mean, I'm doing my, I don't blame it. I would want to leave my talk as well, but. Indigenous, or as we say in English, native to the Indonesian Java Islands. It's a bird that's native to the Java Islands, and it's a bird And birds fly, often in the clouds. So it's a bird that's native to Java that lives in the clouds. It's a cloud-native Java bird. Never mind. It's fine. It'll come. Just give it a second. So there's that, right? And I work at Pivotal, and at Pivotal we have a lot of good open source technologies. How many of you know Pivotal? We're the technology that funds and sponsors the bulk of the development behind technologies like Apache Tomcat. How many of you know Apache Tomcat? All right, good stuff. You're welcome. What about Spring? Spring. Good stuff. Hot sauce, right? So lots of good stuff there. RabbitMQ, Cloud Foundry, etc. Cloud Foundry is an open source project, and the whole point of Cloud Foundry is to help organizations build applications and manage them and deploy them and scale them out easily and painlessly in production. And we care about that. We care about helping organizations go faster. And a lot of organizations, because they want to go faster, they realize that they have to make it easier for teams to release software. And the easiest way to release software is to decompose your software, to make it into smaller pieces. Because the smaller the size of the team working on software, the less prohibitive the cost of actually shipping new releases, of integration testing it, of deploying it, managing it, and scaling it out. The smaller the piece of software, the easier it is to reason about what will happen if I make a change to this piece of code. I formalize the boundary of that code, right? This decomposition into smaller batches of work, into smaller pieces to allow for small teams, we call this microservices. And microservices have become a very common sort of theme these days, right? It's a very, very common architectural construct that helps organizations deliver software better and faster and more safely by reducing the size of the team, by reducing the cost of synchronization in members of that team. And we have seen that while Spring Cloud and Spring Boot have done a great job of covering the very large majority of the use cases you're going to care about when you move to microservices, one thing that becomes a little painful when you move to microservices, if you don't have proper fundamental support, is this discussion of, now that I've got these distributed systems and they're talking to each other over the network process, over the network partition, how do these things communicate and how do they share data? When you move data around a cluster across network partitions, you have a lot of input and output. Input and output reduces your traditional application server's ability to grow, to scale out, to handle more requests. Because you see, a traditional application server is bottlenecked at a single thread. Every single time a request comes into a Tomcat or a Jetty or something like this, a server socket accepts the request, and the response is sent in the same thread. It's in the same response, same transaction, if you will, logical transaction. And this is bad if you have a lot of data. If you're doing something long-lived where, for example, you're streaming a lot of data back to the client, or maybe you're doing something that is fundamentally ephemeral, like WebSockets or server-sent events. In this use case, it becomes interesting to look at reactive programming. And reactive programming, I think, is an old idea that is finally, in the last 4 or 5 years, it's finally matured enough so that there are primitives, there are approaches that we can use in the community to build interesting applications on top of this approach. The fundamental idea behind reactive programming comes from asynchronous event-driven I/O. If you look at the kernels of your operating systems or the core of your operating systems from the last 20 years, they have the ability to say, I have a file descriptor and there's input and output happening on that file descriptor, but it's ephemeral. It happens at different intervals. That file descriptor can publish a notification. It can tell you when that file descriptor has new input or output that's available to be done. And in the meantime, you're not blocking, you're not waiting for it. So it's in the operating system, it's being handled to the lowest level of the stack. And in the meantime, your client user space code isn't blocking, waiting for that activity. This is fundamentally different from the approach that we know about in Java JDK prior to 1.4. Right? We talk about input streams and output streams. This abstraction in Java 1.4 or before, is a lie, right? If you look at fundamental operating system primitives around the network stack, for example, they've always been asynchronous. It's never been that in the lowest levels of your operating system, you can get a synchronous stream of bytes from a socket. It's always been event-driven, your network stack. But in Java, we're used to this, this approach where we just read all the bytes and we wait for it to give us more data until we're done. It's convenient, but it's a lie, right? And it creates poorly performant code. So what we've seen is, in the last 10 years, the last 15 years even, since Java 1.4, we've seen people build on Java NIO, and we've seen basic support, but it wasn't exactly consumable, right? It hasn't bubbled up to a place where we can use it as developers in a convenient way. We had to deal with low-level channels and so on in Java NIO. Eventually, we have toolkits like Netty. How many of you use Netty? Netty is awesome, right? Netty is it's become sort of the de facto standard for building event-driven code on top of the Java NIO abstractions in JDK 1.4 or better. But still, a little low level for most of us. We're trying to build applications, user space kind of things, services. We're not focusing on low-level I/O in the operating system. And so what has happened in the last 5 or 6 years is that different organizations have been looking for ways to take advantage of this event-driven approach and to describe code that works with it without ending up in spaghetti code land, right? Code that's just endlessly complex and mired in all this asynchronous callback kind of heck. So the question is, how do we make it easier? How do we make it easier for people to build applications, user space kind of applications, higher level systems and higher order functions on top of this low level thing? And there have been different attempts, right? There's a lot of great technologies out there. There's Netflix's RxJava. How many of you have heard of RxJava? RxJava 1, right? Lightbend, which is a company that was called TypeSafe up until about like a year ago, they have a great technology called Akka. How many of you know Akka? Right? Very good as well. Red Hat, but originally VMware and SpringSource, have a technology called, or had a technology called Vertex. How many of you know that? That's also a very interesting technology, right? And there are others as well. I'm sure I'm forgetting some, but Pivotal has a technology called Reactor. And Reactor's been around for, 4 years now as well, at the same time as Vertex it started up. And these technologies are all frameworks that build on top of these low-level, event-driven sort of frameworks. But they provide a way to describe asynchronous event-driven code. It's a general abstraction. It's a general framework that builds on top of these low-level primitives. But you don't have to worry about low-level I/O. You're just dealing with event-driven code. Everything becomes event-driven. And if you start to think about the world as being this sort of event-driven thing, then every call becomes something that could potentially asynchronously return a value. What these different technologies strived to do, what they hoped to do, is to plug a gap in the JDK, to fill a very interesting sort of missing quadrant in the JDK. If I ask you today, how do I return a single synchronous value from a method today? String from a method called foo. That's pretty easy. I just return string, I say string foo, right? Parenthesis, parenthesis. If I want to return multiple synchronous values from a method, I say collection of string foo, right? If I want to return a single asynchronous value, I say completable future of string foo. The completable future says this value will be here eventually. It's not here right now. Here's a box that you can hold on to. Here's a thing that you can hold on to that doesn't actually have the value, but when the value arrives, we'll call you. We'll give you an event callback. The question is, what if I have multiple or unlimited asynchronous values? Not just one value, not one string, but infinite amount of values. What do I use to describe that? And there's no real great story for that in the JDK. So out of all these different projects, they have across all of them, they have discovered, they have created types that describe this missing thing, a thing that returns a potentially unlimited stream of values that are asynchronously delivered, right? These projects all have their own way of doing that. And so eventually a standard, a sort of de facto standard, was created. This standard is called the Reactive Streams Initiative. It was created by people working at Pivotal, created by people working at Red Hat, created by people working at Netflix, created by people working at TypeSafe, right, or Lightbend now. So all these different teams work together, and they discovered the very essence of what these frameworks are trying to do. They're trying to provide that missing type, that missing abstraction, that missing primitive. What has resulted is this idea of a publisher. A publisher is a thing that produces values, and then a subscriber listens for those values. A subscriber says, I want to listen for a value from this publisher. That creates a subscription. And that's it. That's very, very low level. Those 3 types. Actually, there's 4 types. A component or a class that produces values and listens for values, so it's input and output, is called a processor. But those 4 types are all that we need to be able to answer this question. How do I describe the world of event-driven sort of data where I have a potentially unlimited set of data? This is what the Reactive Streams initiative defines. It's an interop standard. It's a way of these different technologies can talk to each other. Now, this is not enough, again, this is not enough for high-level, sort of high-order programming. You're going to need to care about composition. How do I take data coming from these different data sources and do interesting things with them? How do I iterate over them? How do I transform them or manipulate them or filter them, or et cetera? You need operators on top of this low-level abstraction. And so the different projects, these different projects that I've just mentioned, they've all provided higher-level sort of DSLs on top of that, but keeping in mind or rebasing on top of the sort of interoperability that comes with the Reactive Streams initiative. And so that's what Reactor does. That's what Project Reactor does from Pivotal. And in Spring 5, coming out this summer, we have built a web runtime on top of Reactor. This web runtime is completely asynchronous. So what we're going to do today is we're going to build an application using Spring Boot and Spring 5, which is GA, so snapshots. It may be a little different tomorrow, who knows. And we're going to look at how to talk to that service, talk to that code from the perspective of a client as well. Okay? Now, how many of you have used Spring Boot? Oh, good stuff. Right on. So we're going to build a new application here. I'll go to my IDE. Let me close this. Okay. Open that. Okay, there we are. And we're going to go to my second favorite place on the internet. My first favorite place on the internet is production. I love production. You should love production. Bring your kids, bring your family, bring the whole group. It's great this time of year. The weather is wonderful. It's the happiest place on earth. It's better than Disneyland. But if you're not already in production, then you begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So what we're going to do is we're going to build a new application here using Spring Boot 2.0. Spring Boot 2 is going to be released at the end of the year in December. It's going to be built on top of Spring 5. And we're going to build a new service called the Flux service. We're going to build an application that manages movies, flicks, using the Reactive project, which has a type called the Flux. Okay, so we'll use the reactive web support. We're going to use reactive MongoDB support, and we use Lombok. Lombok is the compile time annotation processor. How many of you know Lombok? It just makes it easier for me to write code quickly and not worry too much about the tedious, soul-annihilatingly boring, getters, setters, two-string methods, equals, that kind of stuff, right? So there's that. And I'm going to use the support in Spring Data for talking to our reactive data source. Now again, Spring Data doesn't have reactive support for every technology because some technologies fundamentally do not support it. JDBC is a good example here. Oracle has, to their credit, talked about doing reactive support in JDBC, but that's Oracle, and it may be another decade before we see that, right? So in the meantime, we have support in reactive MongoDB. We have support for reactive Couchbase. In Spring Boot, however, the only one that's already supported is MongoDB. So we're going to use MongoDB. If you want to lose your data quickly and reactively, MongoDB, right? So here we go. I'm going to build a new service. I'm going to open this up in my ID, and it doesn't really matter which ID you want or have or use. Anything is fine. Okay. Unzip this idea. We're going to open this up. And again, it doesn't really matter what you're using, right? How many of you are using IntelliJ? Good stuff, right on. Hot sauce. What about Eclipse? Good stuff, right on. What about NetBeans? Very good, right on. Awesome as well. What about Emacs? Are you here, sir? Emacs guy? Are you? I don't see him. Huh. Usually when I go to a conference or I give a talk, it's the same guy, the same human being. Every single time I give a talk, I say, who uses Emacs? I do! And then he leaves to go to my next talk. I don't understand. Anyway, I have now an application, a new service. Can you see that font in the back, my friends? Is that too small? It's small. Oh yeah, it is small. Look at that. Let's see. Font. We'll go to the more bigger setting. Okay. How's that? Good? Okay. Thank you. So we're going to build an application. And again, this is a Spring Boot application. What is nice about the reactive support is that it's still Spring. It's still Spring MVC, or what we call now, there's a new module called Spring Web Flux, but it'll feel very familiar to you if you've ever used Spring MVC. And so I'm going to build an entity called a movie. This is a movie that we're going to store in the database, and we're going to use the Spring Data MongoDB support. We're going to say @document. I'll give it a string here for an ID, right? Private string ID. I'll give it another string for the title, and we'll say @ID the Spring Data annotation there. Now I don't want to write all the getters and setters and all that stuff, so I'm going to use lombok. So this lombok annotation will make it so that I get getters and setters and a toString method and all that stuff. And I can also say I want to create a no argument constructor and an all argument constructor, and you can see that that works by here's a little code block here. So we say movie dot get ID can equals hashcode set ID toString, etc. Right? That all comes for free there. Now I want to be able to manipulate and write and save and persist instances of this record in the database. And so again, if you've ever used Spring Data, you know that the right thing to do here is to use a repository. And a repository in Spring Data is an interface. It's declarative. It implements the repository pattern from Domain-Driven Design by Eric Evans. Domain-Driven Design is an amazing book, and if you haven't read it, I recommend that you keep it under your pillow and read it all the time. What we want to do is we want to be able to work with the underlying database. So we're going to say movie repository, like this, extends reactive Mongo repository. So I'm not using Mongo repository, I'm using a reactive Mongo repository. I'm going to manage entities of type movie whose primary key is of type long. Right? Now this reactive repository has methods that provide you support for inserting and saving and finding records in terms of a special type here called a flux. Remember what I told you about the publisher? So here's publisher. There's publisher. So the Reactive Streams Initiative publisher, there we are. Click on this. The publisher takes a subscriber, right? There are different types of publishers though. There's lots of different types out there. And so in the Reactor project, there are two specific types of publishers. There's a mono, and a mono is a publisher that returns one value. Right? So you can cast it and store it as a publisher. And then there's a flux. And a flux is a publisher that returns multiple values. One or many, or zero or many, right? Infinite values. You can write all your code in terms of the Reactive Streams publisher if you want, or you can use these special types if you know that there's a single value versus a multiple value and want to handle it differently, right? So in our code, the Reactive Mongo repository says there's an potentially unlimited amount of data that's going to be returned from the insert call here. It's going to take its data from this publisher, which is going to produce a potentially unlimited amount of data and write it to the database, and the results will be streamed back to the caller as a flux, okay? So this is not a synchronous value, it's asynchronous. It's eventually going to arrive. Now let's go ahead and write some data into the database here. I'm going to create a command line runner. Now a command line runner in Spring Boot is just an object that when Spring Boot starts up, it's going to call this method and it's going to give it a chance to run. It's going to call the VoidRun method, which is the method we're implementing here as a lambda, okay? So I'm going to say to the command line runner, inject the movie repository, and then let's write some data. So I'm going to create a stream of records, and we're going to knowing what we know about these types, let's create some movie titles here. We're going to create like our own kind of Netflix style thing, or actually we're going to call it Net Flux. Okay. So we're going to create a bunch of movies here. I think there's a couple of them that are awesome. So enter the mono void, right? Silence of the lambdas. Get it? Get it? Aeon flux. E2 mono tambien. That's after the E2 mama tambien. That means and you as well, mother. In this case, it means, in Spanish, it means and you as well, monkey. Right? Can anybody else think of some names here that would be appropriate? Does anybody know the movie where remember the movie where they had a flux capacitor to travel in time? Back to the Future, yeah. There we go. Okay, so we've got a few records, and what I'm going to do is I'm going to write these records to the database. So I guess the first easiest thing we could do is to say, let's create a movie out of each one of these. So for each title, we're going to create a new movie object, right? So movie object, and I'm going to pass in my primary key here, passing in the title, and then for each one of those, I need to write the record to the database. So I'll say m movie repository dot save. Okay, passing in m, right? Now, this doesn't work, does it? It looks like it would work, but if you run it, you notice that it's complaining that we haven't done anything. Well, it's complaining that we can replace it with a method reference, but it's also not going to do anything, actually. If you were actually to go to the database, you would see that nothing happened, and the reason is because we haven't executed something with the response. Remember, the response here is a publisher of some sort. So we need to actually tell the framework that as soon as this event happens, let's do something with it. And the way we can do that is to call the subscribe method. And the subscribe method has an overloaded version that takes the movie that was returned, an exception if it was thrown, and finally a runnable to be called on the last, at the very end of the processing. In some cases, it makes sense to call the first one or the second one or even just the third one and then pass in nulls for the previous value. So in our case, what I'm going to say is for each written movie, let's write the records to the database. So let me create a log here, a logger. Let's write it to the console, log factory.getLog. Okay. There's this. And I'm going to say save, and then write that out. Write the response that comes back from the save method each time, right? So there's my code. If we run this, we should see the response reflected on the console. But there's another problem with this code, isn't there? Right now, I'm writing data to the console, and you can see that it's, I've written now these records to the database, and you can see that they're reflected. And that's very good, but this is MongoDB. It's not great at keeping data, but if it does keep my data, then in theory, I'm going to end up with a lot of data because this is going to be run every single time this program runs, isn't it? So I want to actually delete all the records in the database first. Then I want to call the inserts, right? So I'm going to say delete all. Then, once that has happened, I don't want to listen to the consumer. I don't want to listen for the exception. I just want to have my logic get run after everything else is done, after the delete all has happened, right? So now I can do that, right? So now, if we try this again, okay, there we go. So there's our few movies, 1 movie, 2 movies, 3 movies, 4, 5, 6, that's it. And it doesn't matter how many times we run this, we'll see the same records, right? We've deleted everything and then we've inserted new ones. So now we've got some basic logic. We're demonstrating dependent calls. One call has to happen only after the other. And because we have these higher order DSLs, these higher order operators in the Reactive project, it's not hard to write the code that does the right thing here. We don't have to use a countdown latch or a cyclic barrier or anything like that, right? This is essentially asynchronous code, but it's clean. It's easy to understand. It's easy to work with. Now, I could do other things here. I could say, flat map, right, and filter and do all these kinds of things that you might be used to doing with the collections. Because essentially, we want you to think about this as a collection, sort of, except that it's asynchronous. It could happen, at different times, right? It's not quite a collection. Now, it's worth understanding that these types, the publisher types, are very important, right? They fix a problem in the basic JDK. Java 9, which is in theory due this year, Java 9 will have support for this basic types from the Reactive Streams initiative. It'll be part of what's called Java Util Concurrent Flow, a class called Flow, based on the Reactive Streams initiative. So these types will be, if you understand them now, they'll serve you when you learn the JDK. All right, we've got data we've written to the database. We've got some records. Now we can build a service, something to talk to it, right? Let's talk about building a very simple service, and let's take advantage of our repository here. We've got some sample data. Let's build a service. I want to build a Flux service, right? Like this. It's going to be a service. Now, this Flux service could be shortened for Flux sakes, or FFS, right? But I've left it as is because I'm happy with it. There we are. So there's that Flux service. And what we're going to do is we're going to use our repository, private final movie repository. And I'm going to create a constructor, et voila. And I'm going to create some endpoints that just serve some basic operations. We're going to create a REST API here eventually, but let's do this. Let's create a few endpoints that are going to be meaningful that we can use. So I want to create an endpoint that returns just a single movie, right? So I'll say by ID string movie ID. Okay, we'll return null for now. I want to say give me all of the movies, right? All. And here again, this is pretty easy. I can just delegate to my repository, but for now we'll return null, right? So Flux is all of them. And I want to see who is watching a movie. Again, imagine we're building something like Netflix where people are streaming videos all the time. I don't actually have, 100 million people using my service right now. Bummer. So we have to kind of fake it. I don't actually have all this event log information that we can stream. But imagine if you wanted to view all the different streams, all the events where people are watching a movie. I wanted to scroll through that list, that potentially endless list. It might go on for 1,000 years, but it'll never end. Right? I want to have an endpoint that gives me that stream. So here I'm going to create another endpoint that returns a flux of movie event. Right? So streams movie ID. And we don't have this class here yet, so let's go ahead and create that. We'll say class movie event. And the movie event type will have the type of movie. It'll have the user that is watching it, and it'll have the date, right? Private date when. Okay, there we go. And now I'll use Lombok as well. I'll say at data, at all args constructor, at no args constructor. And there we go. Now I have a very simple entity that I can use to solve this requirement. Now let's go ahead and implement this service. The first one is very, these first two are easy enough, right? So movie repository dot find all. Voila, no problem, got it. And this one is movie repository dot by ID, or find one rather, movie ID. So those are easy enough. But this one is going to require a little bit of exercise. We don't actually have data, do we? We don't actually have people watching this right now. So we need to pretend, just so we have something that we can use. And again, this is a good example of where we can use these the Reactor project operators to sort of solve this problem. What I want to do is I want to say, generate a new movie event every second. Every second, generate a new movie event, and it'll go on forever, right? So I can use the Flux operators, the Reactor project operators, to compose two different fluxes. One that gives me a new event or new value every second, and one that gives me a new movie event. And I'll zip them together. So I'll take a new interval, and at the same time I'll take a new movie event, I'll merge them together and return that. So the result will be that I will only have a movie event as fast as, I'll have a single value from the movie event flux as fast as the values coming from the duration interval flux will create new values. So once every second. So we'll say flux dot from stream. I'm going to just create a stream here, a Java 8 stream, right? And the stream will use a, oh, here we go. I'm going to use a stream generator, and here all I'm going to do is I'm going to return a new movie event. So movie event. And the movie event, in turn, needs the movie. So we have to write that code a little bit differently. We can say mono of movie by ID equals by ID, movie ID. Okay, there's this. And I'm going to get the ID. I'm going to get the value. I'll say subscribe, or say flat map many. So here I'm going to take the value from the movie mono and just work with the movie itself. I don't want the actual mono itself. I just want the movie. And here, I'll have the movie, and I'll use that. I'll say, give me a movie event, so movie, and I'll create a user, a random user here. And again, it's just arbitrary names. We'll come back to that in a second. And we'll pass in a new date as well. Okay. There we are. So let's create now this method, random user, and we'll create just a fake list of users, okay? So users, JLong, that's me, MK Heck is my buddy who helped me dream up this talk, Desire, PWeb, M Madura Bave, there we are, okay. There's our list of strings, our names. I'm going to say return new random dot next int, and we'll say give us a integer that's in the range of the length of the user's array, and we'll use that to index into the array. So we'll get a random user. There we go. Okay. So there's our values here, our new movie event, etc. Good. Now we want to also create those random values. Remember what we talked about. So we're going to create a new value every second. And this one's much easier to write. We're going to say every 1 second, create a new value in a flux that never ends, or potentially doesn't ever end, right? So we're going to create that and assign it to this thing here. And then we're going to compose these together. We're going to zip them, one from one side, one from the other. We're going to take a new value and return the composite of that. So we'll say flux.zip. We're going to say zip interval and zip this one, which we need to create here. Okay. There we are. And that gives me a tuple with 2 elements in it, right? So what I want to do now is I want to say zip.map, or flat map tuple to get t2, right? Is that right? That's right. There we are. Okay. So now if we look at the results of this, you can see that the result is that I have a flux of movie events only, but it's only going to generate a new movie event every single second. No faster. It's not going to generate a million values. It'll just generate one new value every second because it's going to move in lockstep, because they've been zipped, they've been composed like this. So here I'm saying, give me this movie asynchronously, and then when you have it, use that to generate this thing. In fact, we can merge this together, keep it a little cleaner here, like so. Get rid of this. We don't even need this anymore either. That gets a little cleaner. There we are. So now I've got a endpoint that will stream data that we can look at and inspect as we need to. Okay, so we don't need this either. There we go. So there's my 3 service endpoints. Now we can build a REST API, and this is, I think, where a lot of people will be interested. We have a runtime in Spring 5 called Spring Web Flux. Spring Web Flux builds upon these operators that we're looking at here in the Reactive project and in the Spring ecosystem at large, and supports building completely asynchronous reactive endpoint services. Now, this runtime is in turn built on Netty, or rather, it can work on traditional servlet services if you want them to, but that's going to be degraded performance and degraded functionality because the servlet API is not truly reactive. There are lots of parts of the API that are synchronous and blocking. So this isn't going to be a great fit. But there is also a separate runtime, same code, same everything. You don't have to change anything. There's a separate runtime called that's based on Netty rather, and that Netty runtime is what we're using by default here. So I've got now a FluxFlix service. Let's build a REST controller. This is the traditional way of trying to build a REST API, right? So FluxFlix REST controller. And I'm going to map the endpoint. We're going to say at request mapping. 2/movies, okay? So let's create a few endpoints here. Let's see. We want to create a endpoint that returns a mono of movie by ID, string ID, okay? Same as before. Want to create a flux of all the movies. There we are. Okay. We want to return the streams as well, so the movie event stream. And again, this is where this completely reactive support comes into its own, right? Is because we don't want to lock up that single server socket that's handling the response here. So let's go ahead and build this endpoint. We're going to say at get mapping, and this one will return by ID, so it'll take a parameter ID. This is a path variable, right? So there's that one. We want to return just all records, right? So we'll say movies. I guess we don't need that, right? And then this one will just return all of them, so we don't need that. And then this one will return by ID and just the ID. And so we're going to say at path variable string ID. And we can build on our service that we've just created. So we'll say flux service, provide that as a constructor argument. We're injecting that using the constructor here. And here we go. We can just say flux service dot all. That works fine. That's going to work as you expected. Flux service dot by ID, passing in the ID. There we go. That works as well. But this one, it's mostly a pass-through, isn't it? But we need to do a little bit more, because what we want here is we want to serve the data to the client. And the client, if you're using REST, the client is going to expect to be able to load the whole page, the whole document, and then go to the end of the file and then start processing it. REST isn't built for endless, potentially unlimited amounts of data. What we want is to send back a response to the client that may never end. Oh yeah. Good stuff. So we want to handle a potentially unlimited amount of data here. And so we could use technologies like WebSockets. WebSockets are, they can do server-side push. You can send back to the client, right? When there's data available, I can say, here's new data to the client. It's also nice because WebSockets are bidirectional. I can send requests from the client to the service, and I can send replies from the service to the client, right? It's a full multiplex kind of communication protocol. That would be a good idea, and it wouldn't be hard to make it work based on these APIs. But we can also use server-sent events. Server-sent events are a little bit more convenient because they look like JSON. They have JSON payloads, but they have framing. There's payloads that are framed by spaces and so on. So it's a protocol. It's a unidirectional protocol. So data gets sent from the server to the client, and it just keeps on going. Good for anything where you have a unidirectional sort of heartbeat kind of thing, right? All right. So we're going to use, go away. Sorry. Okay. So there's this. Now, I'm going to tell my code here. Value equals produces equals media type. I'm going to say that this is a service-send event stream as opposed to just a JSON payload. So I'm going to describe the media type here. Okay. So if everything goes to plan, that should work. It should be up and responding to requests at /movies /ID /events /movies /ID, etc. Okay. There we are. And we'll try that out in a second here. Just making sure my go away. Okay, so we've got this service. It's up and running. Let's go ahead and try it out. Okay, so we'll say curl HTTP localhost 8080 /movies. That should have given us everything. Why didn't it? Oh, movies / right? There we are. There's our records. We can prove that it's working by going to JSON PP and printing out the results. There we are. And we can look at a particular record. We can say silence of the lambdas, curl this ID, that should work. Okay, there we go. There's our single record. Now what about the events? The service and event stream. Cool, right? Every second we get a new value. But in that second, in the time between that second, the socket is not being kept. There's no I/O happening on the server side. It's moving the input and output down to the lower levels, which means that the server can now handle more requests in the meantime. It's not blocking. Right? So we're taking as little time as we need to be able to process the single request, and then otherwise it's completely moved out of the foreground, so to speak. Okay, so this is not bad. Now I like this approach. This is the traditional sort of approach to building REST APIs with Spring MVC, and you may be familiar with this. How many of you have used Spring MVC and built a REST API of some sort? Okay, so you know this is very kind of traditional. There's another way to do it in Spring Web Flux that I'm a big fan of. This is called the functional reactive endpoint, or we call them functional reactive endpoints. And the way you build those is you create a router function, like so, routes. And here, I'm just creating a Spring Bean. I'm going to inject the Flux service like this. And I'll say return router function dot get, router functions dot route. And here, I need to describe how I want the predicate to use to match the request. So this is going to be an HTTP GET request to /movies. And I'm going to return I have to provide a lambda here of type handler function. And actually, this is one of those things where you can actually create it in another class, another component. So public static class route handler. I like to create it. You can inline it if you want, but it gets a little confusing if you're not paying attention. So server response all server request, not Corba. Don't use that one. You'll be in for a world of hurt. And we're going to provide the Flux service there. Provide that. Okay. We'll say Flux service dot all. And what we're going to do is we're going to return a server response. So server response dot OK dot body. And what we're going to do is we're going to say, when we have a body, we need to turn that body into records. We need to serialize it out as a collection or an unlimited amount of data whose types are of type movie, right? So here we go. Oh, it's going to be a mono, right? A mono of server response. There we go. So there's our route handler. We can inject that and use that instead of the service directly. So route handler. And here we say handler all, okay? There's one endpoint. And that's all, very clean. It's very sort of, you can see what's happening in the same place. It's easy to understand what's happening. You can clean it up a bit if you use static imports. So there we go, route. Now I'm going to say, let's create a new endpoint here, a new reactive endpoint. We'll say get movies /ID. And same as before, we need to provide a handler method. So here we say mono of server response by ID string, server request. And we say server response dot OK dot body. And here we're going to say Flux service dot by ID, taking in the path variable from the request. So request dot path variable is equal to ID. And we're going to send back a collection of movies, or a single movie in this case, as before, right? So, very good. And we can write this code as well to use that. So we're saying and route. In this case, we're using handler by ID. And then finally, we want to do the same thing as we did before for the service and event stream, right? So we're going to say here, mono of server response streams server request. Okay? And here we say server response .ok.body, or sorry, .content type. Don't forget this, right? Media type, text event stream, and .body. And what we're going to do is we're going to say Flux service streams, passing in the request get or path variable .id of movie event .class. Okay. So same as we did before in every other way. It's just that now we're saying to use these functional reactive endpoints. Okay, much cleaner, I think, easier to see. If you don't have a lot of things and you just want to get it all in one place and you want to have a single view of all your routes, then this can be very, very convenient, right? So ID, events, etc. This is very similar to the sort of Sinatra in the Ruby on Rails world, or Scalatra in the Scala world, etc. Right? Or even Ratpack in the Groovy /Java world. Okay, so there you go. Those are route functions. All of our routes and the handling logic is clearly mapped. It's linked right here, and you don't have to scour the code base to figure out what is doing what. You know, what component is processing the request. And so it's your choice. You can use either one. Notice that I had to comment this out, so it's not easy to get them both to work at the same time. So pick one or the other. I happen to think that this old style is going to be very convenient if you already have code that works the old way and you want to just move it over slowly. So let's try it now. Oh yeah, the movie doesn't exist, of course. So movies. Did I do that wrong? Movies. Okay. There we are. There's our records. Okay, now let's get a single record back. We're going to say movies. And we'll grab this one here. Paste. No problem. Events. All right, good. So we've got now the same kind of thing, just two different styles. Now, let's build a client. You know, if you build a service in the forest, but no client is able to connect to it, did you actually build a service? That's an existential philosophical question with which I'm sure we all wrestled at university. And the answer, of course, is no, you didn't. So we need to build a client to talk to this. And keeping in mind that we've got we've got a reactive endpoint that may return an unlimited amount of data. So this client has to be smart, right? So we're going to use the reactive web support. We use Lombok as well. But we don't need the MongoDB support, right? So we can say Flux client, hit generate, unzip Flux client, cd Flux client, idea pom.xml. Okay, and we'll create a HTTP client that we can use. Now, if you've used Spring before, you know about the REST template. And the REST template still works, but it's not really a great fit for reactive services, things that may return a potentially unlimited amount of data. So we have a new client called the web client, which is in the Spring Web Flux module. Now, I'm going to start this client up on a different port, 8081, just because I don't want it to block the other one. I'm going to say, create a new web client. There we go. And I can use that web client now to visit the data. So demo, and then I'm going to inject the web client here. There we are. Okay. So what we're going to do is we're going to visit all the records that come back. We're going to say client.get HTTP localhost 8080 /movies. Okay. .exchange. Oh, sorry. What is this? Oh, get URI .exchange. And what I want to do is I want to visit all the records that come back from there, right? I want to visit the records. Let's prove that that works. I'm going to say we've got a client response that comes back. And our job is to take that client response and convert it into an object. In this case, I want a flux of movies that are coming from the JSON. So let's grab our little DTOs from this service implementation here. Okay, there's this. Paste it in the bottom. Grab the other one as well, our movie event. Okay, grab that. Paste that here. This isn't, we're not going to store this in a database, of course, so we don't need the Spring Data annotations anymore. Indeed, we don't even need this extra type now. Okay. So now, we can say turn it into a collection of movies dot class, and here we're going to actually transform it, and then we can subscribe to the movies that come back. So let's create a logger as well, just like before. Private final log equals log factory dot get log get class. Write that out and confirm that it's working. So movie.toString, etc. That should be a very simple test. Let's see if that works. We should have all the records that come back. And then if that works, we'll go ahead and try the next thing, which is to get the service end event stream. Okay. 404 movies /. Okay, that seems to have worked. Good, let's try it. We've got 3 more minutes. I think we can do this. Now, what we're going to do is we're going to say, instead of flat mapping, instead of just subscribing, what I want to do is I want to filter the result. I want to say when I find a movie, get the title, see if it equals Aeon Flux, then subscribe to it. What I'm going to do when I subscribe to it is I'm going to work with it to get all the service and events. So I'll say client.get.uri http localhost 8080 /movies /movie.id events. Okay. So there's this code. And here I'm going to say when the response comes back, make an exchange, then flat map it, CR to a movie event type. Right? Then subscribe to that, and let's just log the results as we did before. Okay. There we go. So there's our client, not blocking on the client either. It's going to keep that thread. It's going to keep that thread open only as long as it needs to be able to process, and then it's going to passivate. This gives us the ability to build services that will handle more requests. Remember, per transaction, synchronous I/O is faster. Right? There's no context switching, basically. But in terms of your ability to do more with a single server, this gives you more scalability, more performance. Now, this is just the beginning. We've just looked at Spring Data, which has, where appropriate, Cassandra, Couchbase, MongoDB. We've looked at Spring Boot, which is, Spring Boot 2.0. This is snapshots. That'll be available end of the year. And we've looked at Spring Framework and Spring Web Flux and Spring 5. And there's a lot of great stuff here as well, but there's more coming, because this doesn't make any sense if any part of the chain is synchronous. So, for example, we're working on Reactive Spring Security. That'll be there this year and next year as well. We've got new technologies in Spring Cloud, including one called Spring Cloud Gateway, which gives you an API gateway, kind of like Netflix's Zool, which is completely reactive as well, and it's built on top of Spring 5 and the Spring Web Flux API. So there's an integration end-to-end in the entire Spring ecosystem, so that at no point, if you don't want to, at no point does your code block waiting for unnecessarily. My friends, I appreciate your time. Thank you very much for coming. I've got another talk later this week. If you want to come by and say hi, I'd be happy to talk, and I'll see you at the other talk otherwise. Thank you so much.
Thank you, Josh.